Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 6.5, Inverse Trigonometric Functions. The inverse function of trigonometric functions are used very frequently, even during GCSE. What the point of this video is to teach you what the plot of the inverse trig functions are and what are their domains. So let's start with the first one, which is arcsine. So arcsine is written as follow. Let's take x as our value of interest. So this is the symbol of arcsine. You can technically write ARC sine. They are equivalent, and so it doesn't matter which one you write. In order to find out what an inverse function is, we can try to figure out what an inverse function is by normally just substituting x and y into the opposite location. So if we have a function y equals to let's see, cosine of x, then the inverse function would normally be arc cos of y of x, which essentially equates to such that function of x equals to y goes to arc function of y of equals to x. So technically what we've done here is just simply switching the x and y locations, then it works. It's worked the same for x squared plots and natural log curves. As long as you flip x and y, then you will get the inverse. So same applies for trigonometric functions. So for a sine curve, we all know that it looks sort of like this, with a maximum of 1 and minus 1. Start from 0. There are 3 different locations where it hits 0. There are 0, there are pi, and there are 2 pi. Make sure you use radians for trigonometrics, because that's how it's supposed to be. With that said, however, we're gonna inverse this whole thing, which again, swapping y and x, we get something that looks sort of like this. Let's see. X is positive that way, y is positive upwards. So from this plot we can essentially write that if we reflect by y equals x as a line, then we get something that looks sort of like this. However, for a for the curve, we want to include the negatives as well, so we're gonna extend backwards. So right now we have 2 complete oscillations, but the important thing is the range of your equation or your function would have to be within 2 pi. So it depends on what your limits are. If your y is limited to pi and minus pi, then you should cut off these two. This segment of sine should be the values. But however, there's another issue, because the arc trigonometric function is there's only one value associated So if we have a value of this value, probably minus a half or something, then we cannot have a one-to-many function. That wouldn't be called a function. So we need to cut off everything that repeats, which ends over here and there. So technically what a arcsine function is mathematically defined with a shape that looks sort of like this. So the domain is from 1 to -1. The range goes from half pi to minus half pi. This is just how they defined the inverse sine. So this is something that you need to keep in mind, and make sure you know what this inverse of sine is. You can do the same for cosine and tangent, and I'm gonna let you do that in the questions section. But for now, this is essentially what you're trying to do. You can repeat that for cosines and tangents fairly easily. Yep, as I have said, you can now work on the arc cos and arc tan. There aren't any more, anything special to this topic, so there wouldn't be any tips, because for now you need to get familiarized with this inverse trig function before you can do any form of integration calculus on the inverse function. And yes, you do need to know how to do calculus with these, and I'll tell you how to do that in the next video, the following video of this chapter. So as usual, I'll give you 5 seconds to pause the video and get some work done, and I will show you the answer in 5, 4, 3, 2, 1. Okay, so the answers are shown right here. For the arc cos, the domain turns out to, the domain is always between 1 and -1, as we expect, because that's the range of cosine. Also, the range of this cosine turns out to be all positive, because if you go both positive and negative, you get a repeat, which breaks the definition of a function, so that the negative domain cannot be used. And the only continuous function that you can get out of arc cosine is this following curve, which makes sense. For the arc tangent, there are no clear domain. The domain is all real numbers. You do need to write that down, by the way, so write down all real numbers. So that works. For the y value or the range, it's the same as the continuous domain, and as we know, for tangents, the only continuous domain is from pi on 2 to minus pi on 2. That's the longest one. So or if you are fancy, you go with pi on 2 to 3 pi on 2. That would also be a continuous curve, but normally we include the 0 or the origin value. So yeah, that's essentially what we use, and also that 3 on 2 pi is also the same as minus pi on 2 anyway, because it's a 2 pi cycle. So what essentially that's it for this introductory inverse trig course thingy. The most important thing is what you'll do next video, where you do calculus with the inverse trigonometric functions. If you understand the chapter 6.6, you're gonna go into chapter 6.7 feeling quite confident in actually solving some integration. So for now, that's it for this video. I hope you've enjoyed. If you have any questions, let me know in the comment section below, and I'll try to help you as much as I could. For now, thanks for watching, and I will see you on my next one.